My topic is on Avalanche LIDAR, a new tool for asset mapping in the utility sector. Some of the thing regarding the data is just covered by Steve, so there will be, we will try to focus on the technology side without boring too much. And also we will talk about some of the use cases, how the LIDAR technology is evolving in terms of, people have seen the linear mode LIDAR and now it's the Avalanche LIDAR. So this is what I'm planning to do. Just one slide about my company, the photon counting LIDAR, or we call it as an Avalanche LIDAR. How does it work? And then vegetation management, that is one of the key area for the utilities. And we will also talk about the derivative products. And then question, if there is time available, I will answer a few other questions. So this is about my company from 1866 till running in 2025, various milestones. The most important thing I want to tell you is in 2024, the company acquired the photon counting LIDAR technology. So that's how right now we are providing this service in addition to the other services like imagery and linear mode LIDAR and so on and so forth. So let us get into the technology side. How does it work? So what you are seeing on the left-hand side is the traditional LIDAR. That is what we have been using it for years from the time in 2000, 2001 when the technology started coming in. Primarily, we call it as a linear mode, or it is also called the echo digitizing. Primarily, it uses the individual laser beams to measure the range. Basically, what we are doing with the laser sensor is the range, and we use the individual laser beams to measure the thing. On the other hand, in the photon counting LIDAR, we don't measure the individual laser beam, but rather the returns of the individual photons is what we measure. So that is the fundamental difference from the linear mode LIDAR to the photon counting LIDAR. What is that? I think it will be explained in more in detail. So this is So this is the video talks about the linear mode and the LIDAR mode. So what you are seeing on the linear mode is normally the flying altitude is somewhere around 3,200 feet. The point density is around 8 points per square meter, whereas with a photon counting LIDAR, you can fly at a higher altitude, around 16,000 feet, at a higher speed, 240 knots. The net result is that you are able to cover a larger area in a shorter time. Obviously, that will directly translate into cost. And this is a multi-angle illumination. That means what you are seeing here is your building is illuminated multiple times. So it's like a oblique camera. If you are thinking of a oblique camera, you are seeing the same spot in multiple angles. That way, if some of the areas are obscured, that will be picked up in some photograph or other, unless the area is totally covered by vegetation or something like that. So in the same concept, using this camera, what happens is that you do your two pass. There will be more than multiple views. That way, you can get a very clear view of the object. So we call it as a multi-look oblique angle, and it is a sort of 360-degree capture. So this is a comparison between the linear and the linear mode as well as the photon counting. The linear mode, what happens is a high power requirement. It's 5 to 10 nanoseconds. So what you are seeing here is a single beam, single spot. That is what you are seeing here at the center here. Whereas in the case of Avalanche LIDAR, you can treat that as a 3D camera. And what you are seeing here is, the entire thing, it's a low power, less than 1 nanosecond pulse. What you are seeing is a 4,096 pixels. So that is the type of reflectance or the returns that you get from the camera. So that is a comparison between the linear mode as well as the Avalanche mode. So this is about the camera. Again, I don't want to go deep inside. There are 4,096 measurement. Most important thing I want to emphasize here is please treat this as a 3-dimensional camera rather than a 2D camera we have seen. So this is a 3-dimensional camera. And if you see, so this is how, there is a 2-pass, as I said in the earlier thing. So you will have, with a 50% overlap between the flight lines, what you will get is multiple looks, 4,096 returns or something like that. And that way, I think you will have a very high point density you will get from the LiDAR side. So with regard to the processing, again, this is a core of the processing voxel product generation process. I don't want to, when we get the data, the point density will be at a higher point. Some of them will be obviously noises and other things, so that needs to be eliminated. So we use the process, what is known as the voxel product generation. The most important thing at the end of the process is that you will be getting a LAS file. So only at the time of data collection, up to this stage, only the linear mode LiDAR and the Avalanche LiDAR will be different. Once you do the voxel processing, you will be given a LAS file, and it is exactly same as the LAS file you create from the linear mode LiDAR, which means if you are already having a workflow established using some of the standard software, so you can take your LAS file and process in the same way. So after that, there is no distinction between a linear mode LiDAR or an Avalanche LiDAR. The only thing is it will have more points. So another important thing I want to show the differences here, the bottom, the third one, you can see the distribution. So you see a lot of, each and every grid you are seeing at least a minimum 1 point. That means there is less chance of a data void. Whereas in the case of linear mode LiDAR, there are in some grids you are getting more point, and you can see some grids there are no points. So there is a possibility of data void that is there in the linear mode LiDAR, whereas that will not be there in the case of Avalanche LiDAR. So this is exactly shown here. What you are seeing here on the top left, the graphics is a linear mode LiDAR collected at 2,000 feet AGL. You can see the upper line is completely missing, whereas the bottom, exactly bottom is 12,500 feet collection. You can see the smaller lines are being, you can clearly see because of the higher point density. In the same way, on the right-hand side, the top image is a linear mode, and you can see some of the shadowing behind the trees. That's what I explained in the previous slide. Whereas in the bottom thing, that the shadowing, there is no shadowing or very limited shadowing in the case of the bottom image. So that is a comparison of the LiDAR density between the linear mode as well as on the Avalanche mode. So let us get into the vegetation management. That is what the utilities always look for. So this is, this graphics is simply tells you wherever the red dots are there, those are all the encroachment areas. And this is what the utility companies will concern about. Their job is to, cut and trim, C&T they call, at a different level. It used to be based on a period, but now people are thinking about a condition-based rather than time-based. Earlier it used to be a 2 years or a 3 years, but now instead of that, whether based on the condition, because even if you're able to push 1 year, you will be saving a lot of money on the trimming exercise itself. So there is plenty of things we can do with Avalanche LiDAR. The most important thing is 3D pole and wire vectors. That's a core area for utilities. And then obviously the vegetation management, and then you can do the network analysis, tree analytics, and so on and so forth. So this is a sort of graphics it shows you. I think the original asset line is it is coming as a gray. I don't know why, but in the graphics you should see as a blue line. So the blue line is what the original line the utility companies will maintain. That is their GIS vector. And what you are seeing, the red line, is what has been created from the Avalanche LiDAR. And obviously you have to do some conflation to bring both the data sets together. But what happens is that you can see the density as well as the clarity of identifying the encroachment within the right-of-way. In the case of transmission lines, the width will be more, whereas in the case of distribution line, the width will be less. So this is what I said. You do the vegetation trimming is based on the condition-based cut and trim program versus cycle-based. That is what the utility companies are analyzing that. And there is a published report by the Pedernales Utilities in Texas. They demonstrated almost a $2.5 million savings in their operation cost just by using proper LiDAR data and coming up with a condition-based trimming exercise. So this is another example. This is a distribution line. It's a 2-meter vegetation encroachment. The data has been collected at 12,000 feet. Wherever you see the red dots, those are all the areas that needs attention. Basically, there is an encroachment is there, encroachment is there, so that tree trimming needs to be done. So just to show you the density of the data set that you are seeing here. So this is another example wherein you change the right-of-way width. Then accordingly, you can see from the right-of-way, if it is certain X number of feet, or then you can see the different pictures. The red indicates the vegetation that are present within that particular corridor limit that you set. And the last one, bottom one, is primarily to identify what is the wire height from the water, the lost graphics, because people may recall in 2017, there was an accident in Texas involving 3 Boy Scout students when they were traveling on a sailboat. It was a fatal accident, and then there is regulations have come in now that you need to identify whenever there is a power line is over a water body, you need to know how far the power line is from the water. So that is what the lost graphic shows that. This is about the tree analytics. So you can identify the top of the trees and the crown diameters. And also you can calculate the tree lean as well as fallen risk. These are all some of the byproduct that you get out of the LIDAR. And this is an interesting thing. So you can do an advanced analytics. So there are 2 examples I've shown here. In this case, the one on the left-hand side is a tree. And because you have a very high density LIDAR, you can also have the exact information about the ground, including the slope and aspect, everything. So with the tree height, I think with the slope into consideration, you know whether when it is going to fall, whether it is going to hit. Or if you go into the tree which is on the lower side of the slope, then you can also calculate if it is going to fall in this direction, whether it is going to hit or not. So those type of very detailed analytics can be done with the tree height, with the ground condition, with the elevation information. You can perform those type of analytics. So this is just an example of pole and wire vector extraction. As well as conflation. As I said, the conflation is to be done because the existing vectors and the LIDAR vector, they need to be conflated always. So this is an example of where how the data can be used in extracting information with regard to the pole and wire. So these are all the 3 examples. So with that, I think I get into the derivative products. I want to emphasize here, as I said at the very beginning, once you create the LAS file, after that the workflow is exactly same whether it is a linear LIDAR or Avalanche LIDAR. So technically all the products that you are creating, whether it is under the topographic like elevation model, surface model, terrain model, or slope aspect, any of the contours, any of this product that you are creating under the linear mode, that you can create with Avalanche LIDAR. In the same way with regard to the vegetation, the canopy height and those type of information that you are doing with the linear mode can be done here. In the same way, the buildings can be extracted, hydrographic information can be done, and obviously the utilities is a main player that utilizes the high density LIDAR. So what I'm trying to tell is pretty much all the products that you can create from the linear mode LIDAR can be created from the Avalanche LIDAR without any difficulty. And this is an example of a detailed DTM. So you can see the clarity of the data. And this is a intensity. Basically, there is one thing I need to tell you. Unlike the linear mode LIDAR, where we constantly use the intensity data, there is no such term called intensity with the Geiger mode or the Avalanche LIDAR. But what we do is we use the reflectivity based on the amount of returns from the objects to generate a intensity value. So this is actually created from one of the Avalanche LIDAR. The resolution is somewhere around 7 centimeter, just 7 centimeter. And you can clearly see this looks like doesn't look like a LIDAR point cloud, but it looks like a black and white imagery right now. That is a type of density and the clarity you can get from the data. So this is, so currently we have 3 sensors available. There are 2 aircrafts, which are King aircraft, which are bigger aircraft compared to the normal data collection that we do, because the equipment is bigger, the power requirement is higher, is also more. And the third one is this aircraft, King Air, is a pressurized one. So because you have to fly at higher altitude at 15,000 or 16,000 feet. And of course, obviously, this is a constant thing for everyone. You have to have a strong IT infrastructure to crunch the data. So that is the last slide of the thing. Basically, you can collect larger areas quickly. Higher data density is another one. The foliage penetration, that is what especially one of the questions in the earlier session that was asked about the leaf off or leaf on. That is always a question. I think, when do you collect the data? Leaf off is leaf on. And I think that's what always we want to have leaf on. At the same time, we want to have that, lot of clarity is there in the data. And, reduce the shadows and voids. And it is an high accuracy, even at high altitude. That's very important thing. We can almost get comparable accuracy as a linear mode, 7 centimeters, 8 centimeters, similar to the QL1 LIDAR accuracy in the case of linear mode LIDAR. So one development that has been taking place, we are seeing this at the very initial stage. The LIDAR data has been potentially, or why potential, the LIDAR data has been used by the primarily the state local agencies for topographic applications, elevation related modeling, and so on and so forth. Whereas the utility companies, they have their own program, they collect the data on their own timeline and other things. So now there is a thought process is going on whether you can have a combined program. That means both the utility agency and the government agencies come to a sort of consortium type of thing. You collect the data. So that means you collect the data at higher density, 40 points or 30 points or 40 points. And then that data set can be utilized by the utilities. Whereas then out of the 40 points, you downsample the data to 8 points and give it to the state local agencies, and they can use the data for their application. So that way what happens is you minimize the data collection, or rather you maximize the data usage. So this is something a couple of state agencies are thinking about it. We don't know how much time it will take to reach that stage where there will be a handshake will be there. But definitely looks very positive, and hopefully if it does, then I think you can collect once, use the data by many agencies. So that's about my presentation. I hope I am within the time.